Hello viewers and welcome to Inverse Functions. Really lovely having you here. We're actually following the Cambridge Essentials course for this particular set of videos, so that's an Australian thing. I wonder whether it's in the UK, I don't know. Maybe it is, maybe it isn't. But for those of you who are following along, this is dealing with work on exercise 5G. Those are the questions that I'm recommending to be done. All right, that's over to you to do. If you're watching into the land and just have nothing better to do over a weekend or an evening, it's really good to see you. Now, most of my videos, I've done a recap where I've scribbled in the margins and sort of talked over things. Please remember that function notation is where you have a domain mapped onto a codomain and you have a function of x is equal to, let's just say x plus 3, make it a straight line. So what it means is this describes a function, a line that is x plus 3. So that's going to go through 3. And it is limited between the values of 0 and 4. So before I even go any further, there is no graph there. So I would only have the values between 0 and 4. It's mapped onto this codomain. I say it over and over again, just write it, okay? In university, it gets different. You map onto all sorts of different things, but for methods, it just has to map onto real. Every single function, not relation, every single function you define in methods, be it in a SAC or your exam, I cannot impress enough, has to be in this form, okay? That's one thing. Last lesson we dealt with hybrid functions and, what was it? Wow. Applying function notation. That's awesome. Applying function notation. Really important. But today we're doing inverse functions. Now, I have to say, this comes up in methods 3 and 4. And it, to this day, surprises me that people don't giggle along with hysterical excitement when they see the word inverse function, because there's only 2 things to it. And it really worries me that people find it hard. All right, I'm really sorry. Okay, so the first thing that I need you guys to know is that inverses are so simple. I'm not joking. There are only 2 things that you really need to know about an inverse, and I'll come to those in a second. It's used in methods 3 and 4. When you see questions that mean methods 3 and 4, if you understand this now, you can giggle with joy because it's like, yay, I get this. This is awesome, okay? Please, inverse functions is so simple, right? It is important to note, and it's so important, a function can only have an inverse if it's 1-to-1, right? The other thing I've written here is that all relations can have inverses. Now, I'll clarify that a bit later on, but remember, anything that's an equation, y equals, just pretty much anything, is a relation, okay? We can do the inverse really quickly of any algebraic relation. That's fine. But it's important to note that a function can only have an inverse if it's 1-to-1. Right, so what's a 1-to-1 function? Well, firstly, if you remember, a function is one where the relation can have a vertical line pass through it only at one point. All right, so in this situation, going back to my trusty y equals x squared, that is a function. I can draw vertical lines all the way through that graph, and it will only ever cut once. And as it says here, you can't have 2 y values for an x value. 1-to-1 functions, if you remember, are basically where I draw a graph. If I draw a horizontal line through it and it crosses only once, then it is a 1-to-1 function. In this situation, that would not be 1-to-1 because it cuts twice. Now, we could actually limit the domain of that particular function. So if this, once again, was my y equals x squared, I could limit my domain and say let x only be between 0 and infinity. Now, my graph is 1-to-1. And as such, if it's 1-to-1, it can have this wonderful magical thing called an inverse. Looking over here at this side of my screen, it's so important to note that the inverse of a function is described as f to the minus 1. F to the minus 1 of x. And just to clarify, that is very different. In fact, it's completely the opposite to the idea of finding the reciprocal. Right now, again, if normally we had x to the minus 1, we would know that that would be 1 over x. But in this situation, and the questions generally make it clear, just be aware that f to the minus 1 of x is a way of saying find the inverse of a function. Now, again, when we have to do the inverse of the function, we need to make sure that we know its domain. It'll always be mapped onto R, and we need to know what its new function will be. All right, I'll explain that in a second, but the inverse will have a new domain and it will have a new equation.
Now, don't press stop, not just yet, guys. This is a preview video and you've reached almost the end of it, but it does continue over on mathsguru.com. mathsguru.com, yep, that's my custom website. Bits of it you can see around me at the moment. That has been designed to allow the videos to be easier searched than they are on YouTube. So you can search by chapter, by textbook. Each video has downloadable notes for you, so you can put them in your summary book or your exercise book. There are exam questions, and there is more and more content and more stuff coming as time allows. So head on over there. It's absolutely free to sign up, and I'm doing everything I can to make sure that you guys enjoy maths and actually take out the mastery of maths. It is not as hard as you think. It is all smoke and mirrors. Okay, thanks very much. Take care, guys. I look forward to seeing you in another video. Stay safe.